I found that I've always been a bit of a tinkerer, rebuilding toys that broke into new ones as a child, taking broken toys from my friends as well, and making something entirely new. My name is Aaron Turner. I'm the builder of the model called Noggin. Noggin is a radio-controlled rowing boat, and it's controlled by the transmitter that I hold in my hands. The first thing I remember creating was actually a toy boat. I took one of my bathtub toys. I was around 8 or 9 years old, and I just kept collecting parts that I expected to use. I had some help from my dad to show me what to do, and I put together a motorized boat that I could use in the bathtub. My parents, I think it drove them a little nuts. I had boxes in my bedroom full of bits and pieces, stuff that anyone else would think was junk. I remember taking a battery and the electric motor propeller from an old airplane toy and a drinking straw to make the bathtub toy, and I motorized my little boat. I grew up watching and learning from my parents and grandparents that if you need something, don't buy it if you can make it. My parents provided a lot of opportunity and showed me how to learn to do things on my own. Ever since then, I've been tinkering with bits and pieces and putting new things together. I've built a lot of models in the past. Cars, boats, planes, all at different scales. I've used different types of materials and different methods of building for making my own boat hulls or using existing boat hulls. And I've even done a few ships and bottles. I don't have a formal background in robotics. I did do some basic electronics training to get my ham radio license when I was a teenager. Beyond that, I've just had a lot of fun playing with bits and pieces. I've always been fascinated by science fiction movies, especially the ones that came out while I was a kid. At the time, I have to realize those movies were made with the best technology that was available to use. A lot of times there was a person in a costume, for example, in a robot. Now, that's entirely different. It's real stuff. That's really fascinating to think of. Just imagine what we'll be doing in another 40 years' time. It took me quite a long time to decide exactly how to build the rowing mechanism, because I wanted it to look like someone rowing a boat, not a mechanism. What I really wanted to do was make the mechanism simple. I've been researching a lot of different ways to make these little rowers work. Lots of methods, lots of very complex mechanical clutches. Some are very technical with microcontrollers, for example, and the list goes on. I wanted mine to have as few parts as possible and be efficient to make and easy to maintain and look like the real thing. Once I had everything planned in my head, it only took about 4 months to build. I came up with my idea using a couple of servos. The oars will fall back into the water under their own weight, so it just takes one servo on each side to lift the oar up and another servo on each side to power the oar forward and aft. The way he's attached to the oars is with his thumbs. Those are little ball and socket joints. on the end of each oar, and his thumb is the socket. His fingers don't actually touch the oars, but the visual effect from a distance is that he's holding the handle of the oar. His elbows and shoulders are loosely articulated inside his shirt, and his torso is sprung so that he's naturally always leaning back. When the oars are pulled forward, his arms straighten out first, and then his torso leans up. And it really looks like he's reaching to put the oars in place for the next pull. With the way I've got the motors set up, I can operate each oar independently with a full range of motion, up or down, front and back, or anywhere in between. They can be positioned anywhere I need them to be or move anywhere I need them to move. And that's in order to do the proper style of rowing or maneuvering that you would need the boat to do if you were sitting in the real thing. Most commonly, when you build a radio-controlled model or use one, the operator is oriented as if they're facing forward in the direction of travel. So you'd have a throttle control, a steering control, and it would be the same direction your mind would expect it to work. This model is a little different. You have to position yourself facing backwards. For example, when the boat's traveling ahead, your left hand is controlling the starboard side oar in the forward direction, but you're sitting backwards. There is quite a lot going through your brain as you're trying to run it. The controllers are set up so each handle or each stick of the controller behaves like the handle of the real oar. You can pull it back or forward or up or down to make the oar move, but you do have to picture yourself in the boat as if you're sitting facing the stern. So these allow the oars to go up and down. That string comes out along the side and just pulls the inside of the oar handle down. And when you let it go, the oar falls back into the water under its own weight. The blade end of the oar floats a bit, and that will rise and fall slightly with ripples on the water surface, which simply adds to the natural appearance of the model. The rower himself doesn't do anything other than follow the oars. I didn't make the electronic components for the radio control. I also didn't make the boots, the jeans, and the plaid shirt. I bought those online. When I was building it, I decided exactly what scale I wanted it to be, and when I went looking online, I found there was actually a lot available for clothing. More options than I imagined. I went with a traditional West Coast look. I made the life jacket myself. I used an old life jacket from when I was a kid, took the fabric apart and the foam out of the inside. I made a pattern to fit the little man, and I stitched up a new life jacket. It looks just like it should. I was quite pleased with the result. You'll see, of course, that he's topped with a red toque. My dad, who used to take us out on our boat when we were kids, has one just like it. When he was young, my grandmother knitted him a red toque. He still wears it today, and he just turned 79. Since this was getting closer and closer to looking like the real thing we had as kids, I decided it needed a red toque. To make the toque, I had to learn some simple knitting. I got one of my daughters to teach me how to do spool knitting. I then sat down one evening and worked at it until I made a toque. I even figured out how to get the little pom-pom on the top. I think I've developed quite a workshop in my house where I can craft on things when I'm inspired and make something that wasn't what it was before. I've only taken the boat out a few times now, one of which was for filming during the atmospheric river rainstorm in November 2021 at Richmond City Hall. Before that, I had the boat on display at the Richmond Maritime Festival. That was the first time displaying it anywhere. There were a lot of people who stopped by for a closer look. At the time, the rule was to wear masks indoors, and this little guy was indoors with everyone else, so he needed to have a mask as well. I took one of the common disposable masks and used the material to make one for him, just to keep him safe also.
When you're building something like this from scratch, there's always something that isn't going to work. And when that happens, you just need to keep working at it and keep rethinking it until it works properly.
One example of things not going the way you want them to resulted in how I picked the name of Noggin. His head is a separate piece of wood from the torso, and it's roughly the size of a golf ball, perhaps a little smaller. It started as a block of wood that I carved into the profile for the face, and then had to carve further down to get it round. I was using my disc sander on my workbench at home, and I was holding the little head against the sanding disc. As I worked the head down into shape, it became more round and, of course, more difficult to hold onto. Eventually, it grabbed onto the disc sander and shot away from me. It went straight up and hit the ceiling of the garage and left a dent in the roof, and I never did find it. I had to start again, so I carved a new head, I cut out a new block of wood, and worked it down pretty close to the same spot, and it happened again. And that time, the head shot out through the door of the garage out onto the road. I never did find that one either. The third one got me in the eye. I was wearing goggles, luckily, but I didn't find that one either. It just disappeared. So the fourth one, finally, I got smart and I used a Dremel tool instead of my bench sander, and that's how I got the one that's on the model now. After all that, I decided Noggin was the only appropriate name for the model.
Noggin is partially considered a robot in the sense that it is an electronic mechanism that moves to make itself move. It doesn't have its autonomous self-thinking, but it wouldn't take much for something like that to happen in a mechanism like that. All it would need is a processor, some proximity sensors, and perhaps even a GPS unit so that it could follow its own instructions and operate by itself.
We can get Noggin's perspective on the world by adding a little camera on board, kinda like a drone. Noggin's a toy, and it's a very wonderful toy, but the idea of putting technology to work in different ways certainly has lots of potential. I have future plans for more models. I have one in mind now. I've actually started. I've collected a few parts and I've started working on the hull. I'm not going to share what it is at the moment, but I can tell you it would not look out of place beside Noggin. This project has been great fun. I got to build something that I find pleasing to look at, and what I've discovered is that a lot of other people seem to enjoy it as well. I've always loved making things work and putting things together. I'm quite certain I will always be either building something or planning what I will create next.